Okay, so here's a second problem that I thought might be helpful. You've got a mass attached to a spring, and it says that is pulled toward the floor so that it hangs above the floor. So here's your spring with a mass attached to it, okay, and it's pulled towards the floor. And it says the height above the floor 10 meters, 10 millimeters. Okay, so 10 millimeters above the floor. The mass is then released, and so it starts moving up and down. So the spring is just going to go up and down and up and down and up and down. And it says it reaches the minimum height of 10 and the maximum height of 20. Okay, so the highest it's going to go is 20. So a spring is going bing, 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 back and forth. So if you graphed this over time, you know that it's going to go no lower than 10. So at times 0, you're going to pull this thing down and it's going to have 0 at 10 millimeters high. And then after a certain time, it's going to reach the highest, which is 20 millimeters high. Okay, so it says above the spring, 10 millimeter mass is released, starts moving, maximum minimum of 10 and 20, 20 and 10 respectively, with a cycle of 0.8 seconds. So that means one cycle, 0.8 seconds. So that's a period. So 2 pi over b is equal to 0.8. 2 pi over 0.8 is equal to b. So if I reduce that down, the b value is pi over 0.4. Okay, and I can leave it like that, or I can multiply it 10 pi over 4 if I want. I'll just leave it like that, it's fine. All right, so there's your b value. All right, so that means that if I pull the spring down and I let it go, the next time it's going to be down at 10 is going to be 0.8 seconds later. So if I do 0.8 seconds later, it's going to be back down here. Half of that is where it's going to be at its highest. So there it's going up and down, up and down. Okay, so we know our max is 20. We know our min is 10. So the A value, which is your max minus your min divided by 2. So 10 divided by 2 is 5. We know your D value is your max plus your min divided by 2. So that's 15. And you can see where the 15 is. The 15 is your midline. Right there. That's where 15 is going to show up. So looking at this, it's starting low. That's a cosine graph. So I know what A is. Okay, so A is 5, and it's starting low, so it's negative 5. Cosine, the B value, it doesn't shift at all, so there's X, and then plus D, 15. So there's the equation of this spring going up and down and up and down. Okay, now it also says find for how many seconds is the height of the mass above 17 millimeters over one cycle. So it wants to know how many seconds is it going to be above 17. So if I can see on my graph, 17 is right about here. 17 is somewhere up there. So it wants to know, where is this happening? Where is it above 17? So we need to know what that and that coordinate are, those points, so that I can find an intersection point. So the best thing to do would be to enter my graph. So I'm going to go to a new graph, and I'm going to make sure I'm in radians again. So I'm going to say negative 5 cosine, and then I do parenthesis, let's do pi divided by 0.4, and then an x, and then outside the parentheses plus 15. Okay, I don't know if you can see what I just entered. There it is. Let's hit graph. It might show it without seeing it on the screen, so I'm going to go to menu, I'm going to go to zoom, and I'm going to go to fit, which is the letter A. Oh, there it is. Now, it's because the time, it's only happening in 0.8. So what I want to do is let's change it so that we can see our window, okay, our window settings. Let's not go negative 10. That doesn't make any sense. It started 0 seconds. Let's just go to 1 second because I don't need to know what's going on the rest of the time. There it is for just 1 second. Can you all see that? Okay, so now I want to know what's happening when the mass is above 17 millimeters. So I need to graph. So I'm going to hit tab. I'm going to hit 17, which will give me a horizontal line. So I can see when it's there and there above is where it's bigger than 17. So I need to find two intersection points, that one and that one. So I'm going to hit menu and I'm going to go down to analyze graph, intersection. And I'm going to go a little bit to the left, a little bit to the right. So my first intersection point is at 0.252. So 0.252 in time. And then let's find the second intersection point. Let's go there. Let's go a little bit to the left of it and then sweep it over a little bit to the right of it. It gives me 0.548. So that tells me that if it is between the time of 0.252 seconds and 0.548 seconds, it will be above up here. Okay, so this one right here is your 0.252, and this one over there is your 0.548. So that would answer your question. Okay, so hopefully that will help. I've given you two solid examples to practice.